Hello dear, welcome back. This video will learn how we can interface stepper motor with Arduino. So let's get started. So these stepper motors, these are basically used for precise control of rotational movement. These motors, they can move in discrete steps. That is why they are especially suitable for applications like 3D printer, CNC machine and robotics. These stepper motor, most of them have 4 wires or 6 wires, and you need to connect this stepper motor with appropriate pin of Arduino. In most cases, we use motor driver like A4988 model or DRV8825 model to control the stepper motor. So there are several steps associated with the programming for a stepper motor. The first step is including a library. So the library for stepper motor is stepper.h. The second step is to create a stepper object. So stepper, you need to write this first, then my stepper, whatever name you prefer for your object. Then stepper revolution, you can also define that in previous line like this one, constant int step revolution as 200. Then the 4 pins that you will use to connect your stepper motor from Arduino. So here 8, 9, 10 and 11 pins are used for stepper connection. The third step is setting up the function at the void setup. So here you can set the speed at which the motor should make the movement. Like here you can set the speed at 60 RPM. For that, the function we should use is first the object name like my stepper here dot set speed, and within the bracket you should mention the RPM at which the motor should rotate. Now comes the fourth step, that is to make the rotation. So to make a rotation, you should put your code at the void loop, and for that you can use your object name first. My stepper dot step is the command for making the movement. Here how many steps you want to take for your rotation, you can mention it here like my stepper dot step within the bracket steps per revolution as we have defined here. So this will completely rotate the motor for 1 revolution, then make a delay. So now if you want to make a anti-clockwise rotation, for that you just need to put a minus sign here. Putting the minus sign here will make motor to rotate anti-clockwise. I hope you got the idea. What are the steps? First you need to include the library, then define the stepper object, then set up the RPM using set speed, and to make the movement you need to use my stepper.step function. So that's the requirement for your first program using stepper motor. Now let's see how we can do the simulation for this stepper motor in Okui. At okui.com, let's create a blank case. From here we'll first bring in components related to a stepper motor. Here if you search for a stepper, you will find they have bipolar stepper motor, then a stepper motor driver and biaxial stepper motor. This bipolar stepper motor, this we should bring in on the screen for this project. For simple demonstration, we'll avoid using the motor driver. We'll just connect the stepper motor directly to our Arduino and see how the program works. You have 4 pins here. So the first pin will connect to 8, then 9, 10 and 11. So that's all for the connection. We'll now step into programming and see how we can program for stepper motor directly connected with Arduino. The first step is bringing in the library for a stepper. So stepper.h. You should also bring the stepper library from here, stepper, and if you go down, you will find a stepper library here. Okay, so that's the first step. Now the second step is creating the stepper object. So let's define the speed per revolution first. Const in speed per rev. We'll define this as 200. Then let's define the stepper object using stepper, then put a name like my stepper, and within the bracket first we need to define the speed per revolution, that is speed, and then we need to define the pin numbers here, and we have connected 4 pins accordingly, 8, 9, 10 and 11. We'll just write them here, 8, 9, 10, 11. So that will do the task of second step. Now comes the third step, to set the speed of stepper motor. To set speed, we need to write the object name first. So my stepper dot set speed, and within the bracket we need to define what is the RPM that the stepper motor should run for. So let's define this as 60. So 60 RPM for our stepper motor. Now comes the fourth and fifth step. Let's say we want to move it clockwise. For that, we'll use my stepper dot step. So how many steps you want to move ahead in the clockwise direction? Let's say you want to move 10 steps. Then write 10 here. Then make a delay. So it will move the motor for 10 steps at a time. Then make delay of 1 second. Then again move 10 steps. And this way, this will keep moving in clockwise direction. So let's see if it works. Here you can see, at a time it's moving with a 10 step. Now, if you want to make a complete rotation at a time, like we want to move it 200 steps at a time. So for that reason, we'll give 200. And as we have mentioned previously, 200 means speed per revolution. Per revolution 200 means it will completely rotate one complete 360 degree angle at a step. So let's see. One complete revolution, 1 second pause. One complete revolution, 1 second pause. Now, if you want to make an anti-clockwise movement, for that you can use a negative value here. Let's say my stepper dot step, and within the bracket let's put minus 200 and make a delay of 1000 millisecond or 1 second. So what will happen now? It will completely move clockwise direction for 360 degree. Then make a pause of 1 second. Then it will move anti-clockwise for 360 degree and make a pause, and keep doing so in rotation. So let's see. I hope you got the idea how to program for a stepper motor directly with Arduino. You can also use a motor driver for a stepper motor. Now let's see how we can interface a stepper motor with Arduino with the help of A4988 stepper motor driver IC. So before jumping into the simulation, let me give you a brief overview of the pinout of this driver IC. So here we have V motor, VDD, and 2 ground pin for powering. So V motor, this is basically the motor supply voltage, and this IC can handle 8 to 35 volt for motor input power. And VDD, this is the power for activating this IC. So this could be your 5 volt supply from Arduino board, 3 to 5.5 volt it can handle. And ground, you should connect all the ground together. For connecting the motor, that is a stepper motor, with this motor driver, we have 4 dedicated pins, 1A, 1B, 2A, 2B. So these pins, this should be connected to your stepper motor. 1A, 1B should be connected to coil 1, and 2A, 2B should be connected to coil 2. Now comes the control related pin like step, direction, micro step, and enable. So these pins are used for controlling the motor. Step, that is the 7 number pin of IC. So you can give pulse here. Direction, this is the pin, that is 8 number pin of motor driver IC. If you put high here, it will move the motor shaft in one direction, and if you put low here, it will move the motor in anti-clockwise direction. So you can handle the direction from here. If you are looking for micro steps, then you can use this MS1, MS2, and MS3 pin. Then enable, this need to be remain high to disable the motor and low to enable the motor. So remember that if you want to enable the motor, you need to keep this enable pin to low, otherwise high. Then we have reset, sleep, and fall pin. Now let's see a brief connection diagram. Like just we have mentioned in the pin out, the first 2 power supply related pin, that is the V motor and ground, this should be connected to a external power supply. The next 4 pin, this should be connected to the stepper motor coils. Then ground and VCC of the IC, VDD and ground. This should be connected to Arduino, VCC and ground. Then from Arduino, you can connect only 2 pin and control the motor. The first one is step and the second one is direction. You can also connect another pin to this enable pin. Enable is active low pin. That means it will low to activate the motor, and it will have to put high to deactivate the motor. Okay, so that's the brief connection diagram. Now let's jump into the stepper motor in Okui platform. The programming is similar to the program we have just developed without motor driver IC. Let's see how we can modify that. So as previous, we'll bring in a stepper motor, that is this stepper motor. Then we'll bring the stepper motor driver, that is F1988 driver. The connection is pretty simple. The first 2 power pin, these are related to external power supply. For now, we'll skip that. If you are working on real hardware, you will connect your external power supply here. The second power supply related pins are VDD and ground. So let's connect them first. I'll bring in this VDD, connect it to 5 volt of the Arduino, then ground to ground. So that's the connection related to powering the IC. Now we'll connect the stepper motor with this IC coil pins. These 2B and 2A, these are for coil 2. So let's connect them. 2B, A should be connected to the plus terminal and B should be connected to the minus terminal. Again, A plus, then B minus. Okay. The connection in between the motor driver and the stepper motor is done. Now comes the control related terminals. Then the first one is direction. We'll connect the direction to any of the digital pin. So then step, in this case 9. You can also bring enable to another pin if you want to control the enable option also. So let's bring up here. Okay. Let me change the color so that we can understand it better. So now you can short circuit the reset and sleep pin together. This MS1, MS2 and MS3 are related to micro step. We will skip those pins for now. Now let's come into the programming. The program is similar as previous, so I will make it quick. First step is adding the library to the program. Don't forget to add the library at the library manager also. Search here for a stepper. Then go for a stepper here. So that will be all. Now we will create the stepper object. So I will just paste the code here. First, we have taken constant in stepper revolution as 200, and then stepper, this is the object function. Then we'll write my stepper or any name. Then stepper revolution, this is the first thing you need to write. What is the stepper revolution? The value here. Then 9 number pin, that is the step pin first. Then direction. So for a step, we have chosen the 9 number pin. That is why we are writing 9 first. And direction, for direction, we are using the pink color pin. That is the 8 number pin. So first step, you need to put a step here, then direction. If you are using 2 pin mode, okay, using this driver. Now let's program for the configuration. We will set the RPM speed and we'll also set the enable mode here. So let's paste the code here. The enable pin, it's connected to 10 number pin of our Arduino. So this one, this is the enable pin. We have connected to 10 number pin. That is why we have first defined it as output, and as it is active low IC, that is why we are putting low to enable the motor driver. And we have also used set speed for setting the RPM. Now let's come for the main program, that is setting the movement at the stepper. For clockwise direction rotation, we can just simply put my stepper, then step, and you can give some stepper rotation here. How many steps you want to move, you can set it here. So let's see how it works for this 2-line of program. Now let's put the code for anti-clockwise rotation. Just make it a negative sign here before the stepper revolution. So it will move clockwise, and after some time it will move anti-clockwise. So in this program, we have briefly introduced the concept of A4988 IC, its pinout, how we can configure it with a stepper motor. For some precise angle control, you should explore this code for yourself. I'm not investing any more time with this program because the video has got a way bit long for this demonstration. That's all for this video. I hope you got all the basic ideas about a stepper motor drivers. There are many other drivers also, like this one. Whichever driver you have at your hand, you should look for its dataset or its tutorial on those specific IC, and it will help you to program for your stepper motor. I will see you in the next video with some more exciting stuff. That's all for this video. Thank you.